Okay, I set this up, I took measurements, and I set the RPMs, so the top sprocket was getting 601 RPMs, and the 32 sprocket was getting 297 RPMs. Then I did my measurements, my calculations. I ended up with sprocket to sprocket. I have 15 and a half inches, so 31, it's times 2. And then the large sprocket is 30 teeth divided by 2. And then the small sprocket is 15 teeth divided by 2. And then I have to finish the calculations of n the number of teeth minus the number of teeth. I'm going to go over all that and put that in my write-up. And then times 1 over the sprocket. Okay, the large teeth, the large sprocket. So, so I took the belt or the chain off. I took the chain off and then measured it. I came up with 42 inches on the belt, and the calculation I get after that will be should be 42 also. So now I put the chain back on. I didn't change anything. Okay, I didn't move any of the tension. The tension should all still be the same. So now we're looking at trying to aim this measuring device and the camera at the same time. We're at 602. Okay, and we're at 301. Now that's after I took the first reading, so I actually went up 1 RPM, and on the 15 tooth sprocket, and I went up almost 10 RPMs on the 30 tooth sprocket. So those calculations will work out. One of the things I did was I added more tension to the chain to view its habits, and the small sprocket fluctuated. It pretty much stayed the same, but the large sprocket fluctuated between 4 to 500 RPMs and 12 to 1300 RPMs, which tells me that it was the small sprocket was pulling it, and then there was a lot of play over here, so it was kind of just being jerked into motion. So it really wasn't an effective transfer of power, and I'll cover that in my write-up. Okay. So I think that's what we got there. I think that's what we're looking for. We have a very efficient transfer of power.